Hello and welcome back. Today I'll be reacting to another video, a space related video. This one, why it's so difficult to get to Uranus. So let's just check this out.
Uranus is the seventh planet in the solar system, the third largest and the fourth most massive. It is a gaseous planet that has no surface where humans can walk. For years, space agencies, in space to NASA, have sent various exploration probes to investigate the solar system's planets. Still, it seems that every time new missions are proposed to the planets, Uranus passes completely from being perceived, in fact, is ignored more than its farthest twin Neptune. To date, only one exploration probe has visited this planet, and it was Voyager 2 that quickly passed close to it in 1986 solely to gain momentum. So why is there so little interest in exploring this planet? Is it so difficult to reach, or does it simply have nothing to offer us? The rarest of all. Despite its bad reputation and few exploration missions, Uranus is not a boring planet at all. On the contrary, it is one of the strangest and most exciting planets. With a volume 60 times that of Earth, this planet has a compressed mass of toxic gases. Uranus is similar in composition to Neptune because the two are different from the other gas giants, Jupiter and Saturn. Because of this, astronomers sometimes classify them into a different category than what they call the icy giants. Uranus's atmosphere, although similar to Jupiter and Saturn, which is composed mainly of hydrogen and helium, contains a higher proportion of ice and water, ammonia, and methane, along with traces of hydrocarbons. It has the coldest planetary atmosphere in the solar system, with a minimum temperature of 49 Kelvin, minus 224 degrees Celsius.
How comes? It's the coldest in the solar system. And I thought Neptune was further out than Uranus. So I don't know if it's the chemical composition, but that's as the person is saying, this is the strangest planet because this is okay. I didn't know about this, but let's continue.
It also has a very complex cloud structure, arranged by levels, where it is believed that the lowest clouds are composed of water and the highest of methane. In contrast, Uranus's interior is composed mainly of ice and rock. Because of this, Uranus does not have a solid surface. In fact, none of the gaseous planets have it. There are no definite limits, nothing to stop or sail on, just a mixture of gases and liquids that continuously mix until they reach the core. Why is it the only one totally inclined? Uranus's axis of rotation is sideways concerning the solar system's plane, with an axis tilt of 97.77 degrees. This produces changes in the seasons in a completely different way than the other major planets. The rotation of other planets can be visualized as spinning tops, inclined concerning the solar system plane, while Uranus rotates like a ball rolling inclined. When the solstices of Uranus approach, one pole continuously faces the sun, while the other is in the opposite direction. Only a narrow band around the equator experiences a rapid day and night cycle, but with the sun very low above the horizon as in Earth's polar regions. On the other side of Uranus's orbit, the pole's orientation in the sun's direction is reversed. Each pole receives about 42 years of uninterrupted sunlight, followed by 42 years of perpetual darkness.
Wow. So how do you measure one day in this planet? If it's on its side, okay, I understand in the other planets we measure one day by a complete movement around the axis on the poles. So for this one, it's on the side. So how do you measure one day? If there's 42 years of sunlight on one pole, and then I'm having a difficulty about that. I think I'll have to search this when I get off this, because I'm curious, like how many days does that mean that one day is like a full, lap around the sun? I don't know. Let me know in the comments if you have any idea about this. I just watch these videos, raw without watching them before, so I'm just getting this information as we go.
Can you imagine that? A planet where the night lasts 42 years. This situation where the atmosphere doesn't warm for decades can lead to some interesting atmospheric properties that don't occur on any other planet. As the equinoxes approach, the Sun aligns with Uranus's equator, creating a period of day-night cycles similar to those seen on most other planets. The most recent equinox of Uranus was on December 7, 2007, and the next will be in the year 2049. A consequence of the orientation of the axis is that the polar regions receive more solar energy during the year than the equatorial regions. However, the temperature of Uranus is higher at its equator than at its poles. The mechanism that causes this circumstance.
How comes? As the author is saying, this is a very strange planet. I don't know why there are not many missions, because in 1989 Voyager 2, since that time, and I don't know how they're able to come up with all this. I don't know if observation from Earth, if there are no probes or something. I don't know how they have so much information about it, but we can conclude that this is even more strange. I thought that Venus was strange, but this I think is even more stranger than Venus.
Is still unknown. The reason why the axis of the planet is so tilted and are not known. However, it is speculated that perhaps during its formation, the planet may have collided with a large protoplanet capable of producing this orientation. Another possibility is that the gravitational perturbations exerted by the other giant planets in the solar system have forced it to tilt this way. A long and challenging journey. As we have appreciated, Uranus is not a boring planet. On the contrary, it is a fascinating and unique planet. But there is an excellent reason why, in the entire history of space exploration, only one mission has visited Uranus. It is challenging. The planet is nearly 3 billion kilometers or 1.8 billion miles from the Sun, 20 times farther away than Earth. As a result, any spacecraft will take up to 15 years to get there, using rapprochement gaps between planets to take advantage of gravitational assists. Another limiting factor that all spacecraft that are sent to the far reaches of the solar system have is sunlight. As sunlight is feeble as we move away from the Sun, instead of solar panels, the mission must employ a nuclear power source, which is much more complicated to build and operate. In addition to being much heavier, and as we have already mentioned in past videos, the heavier a ship is, the more expensive it is, and what space agencies least want is to make their projects more expensive than they already are. Remember that one of the factors that most hinder the execution of space exploration projects is almost always money. Space agencies must justify very well the cost of a mission so that the government is willing to finance it. Another problem that adds up is communication. In a video we made earlier about the Voyager probes, we talked about how difficult it is to communicate with spacecraft that are too far from Earth. The only way to communicate with a ship that visits the icy giants would be to place a large satellite dish capable of emitting signals that manage to reach the Earth. As you can imagine, this would mean, again, increasing the weight and dimension.
I didn't know there are so many challenges. Even when you think about the Voyagers made in the 80s, I didn't know there are so many challenges that that accompany the space exploration. Because looking at this, you can already see that there is so many things you have to put into consideration before you launch even launching the thing itself. You have to consider the weight, the communication, the distance it will travel there. So many things, the financial implications. So it's I think even as much as the person is saying that Uranus is unexplored, I'm now getting why some of the things why that is the case.
Dimensions of the spacecraft. Not to mention the difficulty of receiving and sending data at those distances. The radio signals sent by a spacecraft take more than 20 minutes to reach Earth, and the communication between the receiver and the sender would consist of 40 minutes, which is a long time. Therefore, a ship heading to Uranus would have to have programmed a series of tasks that would have to be executed automatically and without human intervention, something that, although it sounds simple, it is not if we contemplate that a spaceship moves at more than 20 kilometers per second in interplanetary space. An error of 1 millimeter in any direction would be the end. Another significant and little moves at more than 20 kilometers per second in interplanetary space. An error of 1 millimeter in any direction would be the end.
So just imagine you have overcome all those hurdles, the finances, all this. You launch the thing, and then you just make a mistake of that 1 millimeter, and then the thing is gone. It misses its target. You might lose communication. So wow, I think this is why these things are not launched every year, and I am now coming to understand why.
Another significant and little talked about obstacle is keeping both engineering and operations mission teams together for as long as it takes to complete the mission. This can be up to a decade between launch and the spacecraft's arrival on the planet. Although it seems insignificant, this problem is why many missions have had to be cancelled. Even others have been delayed years because the team that began working on a mission was not the same that finished it. Information or codes of great importance are usually lost in the passage from one team technique to another. This was just what happened with the Voyager probes, which used VHS-type films to send images, and software made specifically for this task was responsible for encoding them here on Earth. The equipment that performed that job, the software, and the people that knew how to use them no longer exist. So today it is impossible to retake images with the Voyager cameras, even if they work.
But if these things are so crucial and they are so important and they are so expensive, how comes the record keeping is not? They are not doing it because. How comes they would not pass that, even the information? How come they would not record the instructions, everything, all these crucial things to operate these machines? If they are so important and that expensive and they take years to develop. But anyway, I'm just criticizing.
Another example of this problem can be seen in the recent Artemis 1 mission that aims to take the next generation of astronauts to the moon. Many people wondered why the spacecraft and equipment that were used in the 60s were not simply rebuilt. The reason is that all that information was lost. The people who knew the codes of the computers, the passwords, those who made the designs, the mathematical calculations, most of them died long ago. Others replaced the equipment. In the process, all that information was lost, and therefore it was no longer possible to rebuild the ships that took humans to the moon for the first time. As you can see, even before considering what instruments will be placed aboard a hypothetical ship that Uranus will visit, you must consider all this. NASA's new priority. It has become clear that Uranus and Neptune are the least known planets in the solar system. Because of this, NASA has been trying for years to outline the characteristics of a mission to study these bodies in 2030. In 2017, a NASA study concluded that it was necessary to study both worlds. The problem is that there is no money to launch two high-cost probes to the two planets, so it's time to prioritize. One option is to combine this mission with visiting one or more Kuiper Belt objects. Another is to explore one of the two planets. Until now, NASA considered both worlds equally fascinating from a scientific point of view.
If it were for me, I would choose Uranus over Neptune because it seems we have very few information and as I said, it's also strange, all these things coming up, even from watching this video, you can see there are so many strange things about this planet that needs to be more detailed. So if I was given that chance, for me, I would choose Uranus over Neptune.
But in a recent report by OPAG, Outer Planets Assessment Group, the agency has radically changed its mind, and they think that they should give priority to Neptune. Why Neptune and not Uranus? Well, because of, or rather thanks to Triton, the largest moon of Neptune. The decision does not cease to be curious because until recently, Uranus seemed to have won the battle to be the next protagonist of a space mission. Uranus and Neptune are equally fascinating. Voyager 2 discovered Neptune and was more active than Uranus. Still, observations from the Hubble Space Telescope and ground-based instruments have shown that the last planet can be as active or more active than Neptune. On the other hand, Uranus's moon system is the worst known in the solar system, which compensated for Triton's presence around Neptune. However, the proximity of Uranus was the main factor in its favor, since it allows flight times sustainable lower than those necessary to reach Neptune. But OPAG does not support any compromise solution that includes flyby probes to the two planets. The only valid option for them is to send a flagship mission consisting of a 7-ton orbiter equipped with an atmospheric probe that studies one of the ice giants and its system of moons in detail. And
Yeah,
since there is no
I think that is the best approach, to just have a dedicated probe for one planet and its moons, like we saw in Saturn with the Cassini probe. Because that one, it did a very good job with the moons around Saturn and the planet itself, and even finally it plunged into the planet, and it gave out very good data. So I don't think having a flyby of Uranus to Neptune, I don't think it will. The financial cost will not make any sense. So I think it's good to have just one dedicated mission to one planet and its moons.
for 2 orbiters you have to choose. Studying the moon system of Uranus or Neptune on the one hand, the moons of Uranus are the most unknown. In contrast, we know that Neptune has Triton, a moon in which there is likely water. Triton has tipped the balance in favor of Neptune because the community of researchers dedicated to the solar system's ocean worlds has identified it as one of its targets. Neptune's largest moon probably possesses an internal ocean, a mantle of liquid water comparable to Pluto's. After all, Triton is a Kuiper Belt body captured by Neptune. Ocean worlds include Europa, Ganymede, Callisto, Enceladus, Titan, etc. They are a priority for NASA because they are the bodies with the most significant potential for habitability in the solar system. So according to OPAG, NASA's next flagship mission after Europa Clipper should be an orbiter to Neptune. So sadly, and for now, there is no mission to Uranus, at least in the next 20 years. Some scientists are proposing to NASA to prioritize this planet, since the study of exoplanets has revealed that Uranus closely resembles most planets found so far in other solar systems, so that it could be the most common type of planet in the galaxy. However, at the moment, there is still no clear proposal. Do you think we will soon see a new space mission to study Uranus? Do you think we should give more priority to this planet? Let us know what you think.
Yes, I think that we should at least even even if it's not one country, we can have a cooperation between the various space agencies. But I know they don't like to cooperate so much. But at least there should be one dedicated mission to Uranus and its moons. Although, as the author said, its moons are not as interesting as those of Neptune, and that's why there's little interest in it. But I think even apart from the interest, like maybe the having water or something, even the having a detailed, details about this planet, and even the data itself is, I think it would be good to have more data on Uranus, because some of these things you try to find about even the composition itself, if you try to search for it, you see even there's a lot of estimation. It's not as detailed as we have with the other outer planets. So let me know what you think about this. All the questions that have been raised here, you can discuss them in the comments. And until next time, stay safe. Thank you for watching.
Please smash the like button and don't forget to subscribe for more fun videos.